Let's take a look at a second example. Suppose we're given the function f at y equals y squared minus 3y, and we want to evaluate the following. Notice first off what I did. I didn't do f at x, I did f at y. So notice my input is actually a y value. Now that doesn't mean it's the second coordinate in a point. It just means that the name of the variable is y, and that's our input. We proceed the same way we did in the previous example. So first of all, we'd like to compute f at 2. So remember what we do is we take that 2 and we substitute that in for the y every place we see it. So when we do that, we get f at 2 equals 2 squared minus 3 times 2. And if I do the math, of course, 2 squared is 4, and 3 times 2 is 6. So 4 minus 6 gives me negative 2. Now we're going to continue in this fashion. So I have f at negative 4. Again, I substitute in negative 4 every place I see a y. So I'll have negative 4 squared minus 3 times negative 4. Now here's a place we have to be careful, and I made this problem just for this reason. The negative 4 needs to be completely squared, and so I need to think of this as negative 4 multiplied by negative 4. And remember, negative 4 multiplied by negative 4 is a positive 16. If you don't put that in your calculator correctly, it might tell you negative 16 because it will square the 4 and attach the negative. So remember, if you do this in your calculator, or if you're thinking of this, it's negative 4 times negative 4. So here's my 16. And then I would be subtracting 3 times negative 4, which is negative 12. And of course we know 2 negatives gives us the positive, so it's 16 plus 12, or the 28 that we have written on the piece of paper. Moving on to the next, f at b. So what I want to do is do f at b, and so I'm going to substitute in b every place I see the variable. This might seem a little silly in this particular example, but it's because we're moving on to something. So to do f at b, we put b in for the y, and that gives us b squared minus 3b. Fairly straightforward. Now let's move on to f at 2b. Remember, what that means is we're going to substitute in 2b every place we see a y. Now, for some people, it's actually a little bit easier to do a little intermediate step, and if some of these give you trouble, I actually think that you should try this particular step. So instead of doing f at 2b, what I sometimes tell students to do is, let's make it, if that f at b worked for you, think of it as f at box. And then f at box would actually equal box squared minus 3 times box. And then really the only other piece you just need to think of is that the items that are in the box, you want to probably put in parentheses just to make it a little bit clearer. So now notice with my f at 2b, now what I would just do is I would have 2b in the box and 2b in the box, and you'll notice that's what I get over on the right hand side. So I have 2b quantity squared minus 3 times 2b, and if I do the math out, 2b times 2b is 4b squared, and 3 times 2b is 6b. So I get 4b squared minus 6b. Sometimes the question comes up, should we factor this? Quite frankly, unless you are told to, right now I wouldn't worry about the factoring piece. Next example, letter E, f at 3y. Again, very, very similar. I'm going to follow the same set of steps. F at whatever is equal to whatever squared minus 3 times whatever. And I'm going to throw those parentheses on. Now my whatever in this case is 3y. So there's 3y, 3y, 3y. And so what I end up getting is f at 3y is 3y quantity squared minus 3 times 3y. And if I do the math out, that gives me 9y squared minus 9y. Okay, letter F, f at x. Again, this is very much like our f at b question. So f at x, if we just substitute x in wherever we see y, gives us x squared minus 3x. Now, my favorite of all of these parts, f at x plus h, and it's the quantity x plus h. So now let's take a look, and I'm going to do my box thing exactly the same way I've been doing it. So f at box equals box squared minus 3 times box. And again, instead of boxes, I'll do parentheses. And now, instead of box, I have x plus h. So I'm going to have f at the quantity x plus h is the quantity x plus h squared minus 3 times the quantity x plus h. Of all of these examples, I will tell you this is the single most important example. This will appear on multiple exams. We will do it until I believe every single person in the class is capable of doing this particular problem. So let's take a look and let's move ourselves forward. So we have x plus h quantity squared minus 3 times x plus h. Let's take a look at the math. So if we do this, we'll have x plus h squared, which is x plus h times x plus h, and then minus 3 times x plus h. And I started the math out here. I need to finish it off, but I've started the math. So what we have is x plus h times x plus h. Remember our old first, outer, inner, last piece? So if we do that, the firsts give us x squared, the outers give us xh, the inners give us xh, the last gives us h squared. So notice we get x squared plus 2xh plus hx plus h squared. Now don't forget the second part, minus 3 times x plus h. So when we go to do that, remember we distribute, but we need to distribute a negative 3. So that's negative 3x, negative 3h. So minus 3x, minus 3h. Now if we could, we would combine like terms, but it's not going to happen here. We're stuck right where we are.